Let us review the basic properties and formulae in ellipse. So an ellipse is a conic section and we can use the following as a working definition. It is a set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. And the two fixed points are called the foci of the ellipse. Now, a standard ellipse is drawn like this. It is aligned along with the x-axis and the formula for the ellipse is taken as x squared by a squared plus y squared by b squared equals 1. Now in this formula we have made the assumption that a is greater than b. With this formula, the eccentricity of the ellipse is given by e squared is equal to 1 minus b squared over a squared. The eccentricity of an ellipse always lies between 0 and 1. Now the foci are given by the points ae, 0 and minus ae, 0. The directrix are two lines which have important properties, and the equation of the two directrix is x is equal to plus minus a divided by e. And in the diagram we can see that we have drawn them as two vertical dotted lines. The vertices are the points a and a dash and their coordinates are plus minus a, 0. So here's the defining property of the ellipse. Pf1 plus Pf2 is equal to 2a. P is any point on the boundary of the ellipse and f1 and f2 are the two foci. Now Pf1 can also be written as a plus ex, where x is the x coordinate of the point P, and Pf2 can be written as a minus ex. The major axis is of length 2a, the minor axis is of length 2b, the semi-major axis is a and the semi-minor axis is b. The distance between the two foci is given by 2 times a times e, and the distance between the two directrices is given by 2a divided by e. The lattice rectum length is 2b squared divided by a. Now if b is greater than a, then the ellipse is aligned vertically like this. Now the equation is still the same, but the formula for the eccentricity changes. It becomes e squared is equal to 1 minus a squared over b squared. The foci now are aligned vertically and the coordinates are 0, plus minus be. The major axis is of length 2b and everything changes because b is now greater than a. So for example, the lattice rectum would be given by 2a squared by b. Now let us look at the concept of tangent to an ellipse. So if we have to write down the equation of the tangent at the point x1, y1 on the ellipse, then we do it like this. It is x(x1) by a squared plus y(y1) by b squared equals 1. So once again we have replaced x squared with x(x1) and y squared with y(y1). The condition for tangency: if the line is y equals mx plus c, then this line would be a tangent to the standard ellipse under this condition. C squared is equal to a squared m squared plus b squared, and it would be a tangent at this point. Now if the line is given in this form, x cos alpha plus y sin alpha equals p, then this line would be a tangent to the standard ellipse under this condition. The normal is the line perpendicular to the tangent at the point of tangency. So at the point x1, y1, its equation is given by this formula, and it can also be written down in this way. So we have some additional formulae. The equation of the director circle is given by x squared plus y squared equals a squared plus b squared. The director circle has the property that the two tangents drawn from it to the ellipse are perpendicular to each other. The equation of the auxiliary circle is x squared plus y squared equals a squared. The parametric equations of the ellipse is given by x equals a cos theta, y equals b sin theta, and the area of the ellipse is given by pi ab.